Hello everyone, this is Amrtavashni from Rajlakshmi Institute of Technologies, Team Outliers. I am here to discuss a problem statement SIH 1649, which is the cloud's DDoS protection system. First, let's define DDoS as a sort of assault in which hacktivists attempt to prevent a legitimate people from accessing a website or online service by delivering excessive amount of traffic to it all at once.
And now we are discussing about methodology, feasibility, viability, impact and benefits of our idea. A well-trained ML model is used to classify the traffic as a DDoS attack or a legitimate traffic. And for a recovery part, we use load balancers and rate limiters. The main tools used here are Python, Scapy, and Wireshark. In this case, two legitimate users are accessing the server peacefully. But in the case of DDoS attack, the attacker uses multiple compromised computers or devices, often referred to as a botnet, to send massive amounts of traffic to a single target, such as a website or an online service. And because of this, the sheer volume of requests overwhelms the target, causing it to slow down or crash entirely, so that the legitimate user are then unable to access the service. The impact of DDoS attack can range from slowing down a website to taking it offline completely. This can lead to loss of revenue, damaged reputation, and frustrated users.
To overcome this scenario, we use T-Shark, which is the terminal version of Wireshark. Wireshark is widely used for network troubleshooting, analysis, and protocol development. It has become an essential tool for understanding what happens on a network at a microscopic level. As the attack processes, T-Shark captures real-time packets flowing into the server. Simply capturing this data is not enough. We need to distinguish between the legitimate users and the attackers. This is where the power of machine learning comes into play. The captured packet data from T-Shark is fed into a machine learning model, specifically trying to recognize patterns in the network traffic, which classify them as legitimate or illegitimate based on learned patterns and behaviors. In summary, by combining the packet capturing capabilities of T-Shark with analytical power of machine learning, we are better equipped to defend against sophisticated cyber threats like DDoS attacks.
How? As the problem suggests to build a tool that classifies between a DDoS attack and a legitimate traffic, we have tried to achieve that using a simple machine learning model called Hist Gradient Boosting Classifier. And we are very close to do it real time too. So what do we do here? First, we have collected both the packet capture datasets of real-world DDoS attacks and legitimate traffic, and then we pre-process them. For pre-processing, we have a module that we written in Python using Scapy and Pandas that takes a dataset, it extracts features from them and rename them as the model will like it. After those steps, we use supervised learning to train the model his gradient boosting classifier as we label the datasets as 0 and 1 or attack and legitimate or benign, etc. During this process, we're also trying to feed the packets live into the model once every some minutes. It may be 3 minutes or 5 minutes or even be some seconds.
Let me see the recovery techniques for DDoS attack. First, we see Deep Packet Inspection (DPI). Why we choose DPI? Because DPI not only examines the header of the packet, but also effectively analyzes the body. Because body contains the purpose of the packet, so it effectively classifies the malicious packets in the network. After that, the firewall came into the role. A firewall is a security device that monitors and controls the network traffic based on set of rules created by users or organization. Once the DPI identifies the malicious traffic, it alerts the firewall. Then firewall drops that malicious packets from our network. Finally, rate limiting. So rate limiting is used to control the traffic rate in our network. It starts drop packets once the maximum capacity of the server reached to avoid server slowdowns. It can also prevent DDoS attacks. Rate limiting is implemented in network devices such as firewall, router, and switches, etc.
As our recovery part has been completed, now our server is free from the attack and our legitimate users can access it peacefully. Then what about the feasibility of our idea? The idea is quite feasible because the tools and strategies that are used here are focuses majorly on the classification part where there is always room for improvement. Now we can move on to the impact and benefits of our idea. Since our model is an automated system, companies don't have to stress over manual maintenance. Since downtime of companies and their website costs them so much, this model helps the company get their web application back. This is what the whole idea is about.